first flight of the Lockheed XF-104 was conducted in March of 1954. The aircraft displayed good low-speed characteristics and no adverse high-speed effects, other than those attributed to a yaw damper malfunction. This has since been remedied. By the 1st of July 1954, over 80 flights had been conducted on the aircraft. On the 24th of September, the XF-104 was turned over to the Air Force for Phase 2 testing. Presently, this phase of testing has been virtually completed. Remaining is aerodynamic testing with tip tanks installed. To date, approximately 120 hours of flight test have been completed on this aircraft. In-flight gun firing tests are accomplished on the second aircraft. On the third firing flight, the gun malfunctioned. As a result, the loading bolt was blown back through a bulkhead and into the main fuel tank. Fuel from this ruptured tank caused minor engine damage. The pilot executed a successful dead stick landing. Cause of the misfiring is being investigated. Installation of an XMA-10 fire control system in the second airplane is to begin in the near future. At that time, flight testing of the system will commence. The Republic YF-105A contains a bomb bay approximately 190 inches long. It is capable of accommodating a 1,700-pound special store internally, thus preventing enemy recognition of the aircraft's mission. The F-105 is capable of supersonic speeds at 35,000 feet. This is accomplished at the initial combat weight with the special store aboard. The YF-105A, under construction at Republic Aviation, will contain the Pratt & Whitney J57 engine. Fuselage is manufactured in 4 sections: nose, forward section, which contains wing root inlets, center section, and the aft section. The fuselage main splice is located just forward of the vertical tail root. Automatic GCA, a present requirement, will be tied into the autopilot when this equipment is available. This is to permit fully automatic landings under all weather conditions. There is also a tie-in requirement between an AN/APW-11A and the autopilot. This is to assist the pilot in automatically directing him to ground targets. The autopilot will also reduce pilot fatigue on extended missions. The first YF-105A is expected to be completed in mid-1955. First flight will be later in the year. A later version of the F-105, the YF-105B, will contain the Pratt & Whitney YJ75 or J75 engine. First flight of this aircraft is expected in mid-1956. The Douglas YC-124B made its initial flight on the 2nd of February 1954. This is the first Air Force turboprop airplane to fly. The YC-124B has a modified C-124 airframe which incorporates 4 Pratt & Whitney prototype T-34 turboprop engines with Curtiss prototype turbopropellers. Production is limited to 1 airplane. This serves as a flying test bed for the new C-133A turboprop airplane. The C-133A is scheduled to fly in late 1955. Approximately 70 flight test hours were accumulated by the YC-124B in 1954. In April, engine surges limited flight test activities until modified engines could be installed. This was accomplished in December 1954. Presently, it is expected that considerable engine and propeller operating experience, directly applicable to the C-133A, will be obtained from these modified engines. The YC-124B has a design gross weight of 200,000 pounds and a high speed of 323 knots. Its engines are rated at 5,500 equivalent shaft horsepower each. Unlike production C-124s, The YC-124B has a pressurized flight compartment. This permits efficient turboprop operation at higher altitudes. To date, all flight testing has been accomplished by the contractor at the Edwards Air Force Base. Air Force Phase 2 testing by AF Flight Test Center personnel is scheduled to begin early in 1955. The first flight of the YC-130 was conducted on the 23rd of August 1954. By the 4th of November, 23 test flights were made as part of the Phase 1 program. At this time, flight testing totals 19 hours and 36 minutes. Maximum speed reached was 295 knots indicated airspeed at 10,000 feet. Maximum altitude was 20,000 feet. To date, no major problems have been encountered. Performance of the Allison YT-56A1 engines and the Curtiss electric propellers has been excellent. On the 4th of November 1954, flights were discontinued for engine, propeller inspections and engineering changes, test instrument calibration, and completion of airplane structural buildup. Ground tests were completed in December on the second YC-130. Both airplanes will resume flight tests in January 1955. After completion of the air load survey, one of the YC-130s will undergo Phase 2 tests by Edwards Air Force Base. In July of 1953, two Convair CV-340 commercial aircraft were purchased by the Air Force. These were modified to YC-131C turboprop aircraft by Convair at Fort Worth, Texas. Modification on the first aircraft began immediately, and the first flight was conducted on the 20th of May, 1954. During September, this aircraft was transferred to the Air Force Flight Test Center for continued testing. The next month, the propeller vibratory stress survey was successfully completed. In December, a decision was made by all concerned with the project to transfer the aircraft to MATS on the 15th of January 1955. This is 6 weeks ahead of the original 1st of March schedule. The YC-131C is powered by two YT-56A3 Allison turboprop engines which develop 3,250 equivalent shaft horsepower each. The normal gross weight of the aircraft is 47,000 pounds. However, it is structurally designed for a gross weight of 53,200 pounds. Several flights of 50,000 pounds gross takeoff weight have already been made. The YC-131C has a fuselage length of 79 feet and a wingspan of 105 feet. Maximum speed obtained to date in flight tests has been 285 knots true airspeed. Maximum altitude attained, while not fully loaded, has been 39,000 feet. Total flying time accumulated on both aircraft through the 31st of December 1954 is 182 hours. On the 30th of October 1954, the Piasecki YH-16 flew for the first time since its initial flights in the fall of 1953. During November and December, 13 hours of flying was accomplished. These flights investigated rotor system stresses, flying qualities, and preliminary vibration studies. The helicopter transmissions are being disassembled for inspection and incorporation of some redesigned components. It is expected that flying will commence again in early 1955. Caged needle bearings supporting the horizontal pins in the YH-16 hub failed after 240 hours of whirl testing. The testing was conducted at the Wright Air Development Center. This failure appeared to be due to high surface loading and pin deflection, indicating that design parameters are not sufficiently rigorous for use with needle bearings. Fabrication of the YH-16A was completed during the period from October through December 1954. Also, initial run-in of the engines was accomplished. Engine control appeared adequate. Small particles of an unknown nature were drawn into the forward engine inlet during the running. This caused minor damage to the forward engine compressor. Flight testing of the YH-16A is expected to commence early 1955. The first flight of the McDonnell XV-1 convertiplane occurred on the 14th of July, 1954. To date, a total of 10 hours flight time has been accumulated on 2 experimental aircraft. All flights have been in the helicopter regime. An additional 10 hours of high-speed and altitude flights will be conducted prior to conversion to airplane flight. On the 10th of December, an accident occurred to aircraft number 2 during an auto-rotational landing. This was caused by the skid gear collapsing as it dug into the turf. Therefore, due to the destruction of the rotor blades, the flight test program will be set back an estimated 2 months. Past development progress has included improved reliability of pressure jet tip burners, satisfactory control of rotor thrust, reduction of hub pylon drag, refinements to flight controls, and improvements in aircraft stability. Current problems include unknown loss of rotor power, erratic yaw in hovering, and lateral instability in low-speed helicopter flight. Fabrication of the 2 experimental Bell XV-3 aircraft has continued. Approximately 90% of the first article is fabricated. The aircraft was removed from the jigs in December of 1954. Presently, the rollout date for the first XV-3 has been scheduled for the 10th of February, 1955. The fabrication of the second XV-3 is approximately 60% complete. The contractor has constructed a world test stand built from an XV-3 aircraft transmission and drive system components. This is for additional world test and development of the rotor and transmission system. Initial rotor whirl and transmission tests on the contractor's world test stand were started in December of 1954. The vertical takeoff and landing fighter aircraft development program has been centered on the Ryan Vertical Attitude X-13 research aircraft. The tethered test vehicle, used for the development of controls, has been modified to incorporate a pilot seat section in the forward fuselage. Control components of the X-13 aircraft attitude stabilization system have been installed for system test. A second VTO program has been initiated by Bell Aircraft. This is being done with limited USAF material assistance on a horizontal attitude test vehicle. During the past few months, short flights without tethering cables were accomplished successfully. However, after limitations of tethered flight, only 2 minutes of flight were required for the pilot to maintain hovering attitude. This was sufficient pilot familiarization for stable hovering flight on succeeding tests. The Cessna XT-37 is a jet trainer developed under the direction of the Wright Air Development Center. The all-metal low-wing aircraft is the first jet aircraft specifically designed for training. Its features consist of a side-by-side seating arrangement, dual controls, oxygen equipment, jettisonable canopy, ejection seats, and provisions for day and night instrument training. This experimental model is powered by 2 French-manufactured Marboard jet engines. However, production models will be powered by American versions of the Marboard engine. This engine will be manufactured by Continental. The XT-37 is approximately 27 feet long with a wingspan of 33 feet. It will carry a pilot instructor and student. In level flight, the aircraft places in the 350 mile per hour speed class. Its cruise range is approximately 800 statute miles. A unique feature of this trainer is its landing speed of approximately 75 miles per hour. This is considerably slower than that of other types of jet aircraft. At present, 3 experimental models are being test flown at the Cessna plant in Wichita. The first production model, the T-37A, is expected to be delivered by early 1956.